Last time we talked about confidence interval for the sample mean with large samples. This time we are to talk about confidence intervals for the mean value with a small sample size. Small sample means the sample size is less than 30 data. Is more than or equal to 30, we just call large sample, and in this case we want to talk about small sample case. So this case, unlike a large sample case, we will use t distribution. So the reason in this case we are using these cases here because many the real situation you may not collect more than 30 data. Now we are doing practice research. So we voluntarily asked, all the BMCC or other people to take your survey. That's why you may be able to collect 100 samples. But in the real situation, actually we have to pay for each participant. So sometimes it is really difficult to collect more than 30 data. That's why we actually begin with small sample, and then later, if you get may find some sponsor and then something like that, then you can actually increase number of sample. So let me show T table first. So that's our T table here. That's our T table. So as you see this table, so the top row is level of confidence level. This we are using it, and then on the left hand side, the most left column, you will see DF value here. Then we need to know what DF means first. So DF stands for degree of freedom. Okay, then what does this mean? At the beginning of the semester, we talk about sample, then you need to make one empty space, such as sample standard deviation is square root sigma x minus x bar square over n minus 1, right? So then why do you have to do n minus 1 here? Because your sample doesn't always describe population accurately. We want to make one empty space so that we can adjust it. That's why we want to make one empty space. That we just call degree of freedom. Yes, so which means df means n minus 1. So one example, if n equal to 10, then degree of freedom will be 10 minus 1, so become 9 basically. If n equal to 5, then degree of freedom will be 5 minus 1 equal to 4. And this df value is really important when we determine t critical value. Unfortunately, t confidence level C value will be various, unlike Z critical value. Z case, like last time we talked about 3 were major value, 90% 1.645, 95% 1.96, 99% 2.575. Unfortunately, T case, we have to find appropriate confidence level value on this table. So you need to practice a lot how to find it. Okay, then let's look at one example. Constructing a confidence interval for the mean using T distribution. You randomly select 16 coffee shops. So as you see, the sample size is less than 30, so we can make n equal to 16 here, and measure the temperature of the coffee sold at each. The sample mean temperature is 162.0 F, So we can say x bar equal to 162.0 f, and a sample standard deviation of 10.0 degrees. So s equal to 10.0 f degree here. Find 95%, 90%, 99% confidence interval for the mean temperature. Okay, so let me explain about 95%, and then you may try 90% and 99%. I may post another video those other cases using my different problems though. Okay, so step 1 is you need to find degree of freedom, which means df value. So df equal to 16 minus 1, which is 15. So now on this t table here, you will look at 15 here basically. Okay, now we want to find out 95%, right? 95%, which is basically 0.95. So on top part here, you look at 0.95 right here. Okay, and then find the intercept point, which is here and then here. So that's the right number. Okay, so that will be our 95% T critical value, 2.131. So T 0.95, in this case 2.131. Let me double check. Yes. Okay, now step 2, we need to find error. Before z-score case, error was zc times sigma over root n. So this case it will be t-score. So this case error equal to t critical value times s over root n. So if I apply all this value, then error equal to 2.131, that's we just found here, time s, which is 10.0, so 10.0 over square root 16. Okay, if you calculate that, you will get 5.3275. So now population mean is between x bar minus e and then x bar plus e. Therefore population mean is between, the mean was 162, so 162 minus 5.3275, and then 162 plus 5.3275. Therefore the answer mu is between, so 162 minus 5.3275 is 156.6725, and then 162 plus 5.3275 then become 167.3275. That's the answer for this part.